In this problem, we are going to consider a series circuit with a resistor and two inductors. So we've got a time-varying signal that is, let's see, I think it doesn't really matter. We'll just say 1 volt, and the frequency is 240 hertz. And we're going to have an inductor, a resistor, and another inductor. And so the top inductor is going to be 200 millihenries. The resistor is going to be 1.5 kilo ohms, and the bottom inductor is going to be 1 Henry. Okay, so the first thing we need to do is we need to calculate the inductance, the reactances for each of the inductors. So let's say our X, we'll call this one L1 and this one L2. So XL1, the inductance or the reactance for the first inductor is going to be 2 pi FL. That's equal to 2 pi times 240 hertz times 0.2 henries. And so that's equal to L1, X of L1 is equal to 364, 364 and 90 degrees. And then XL2, using the same equation, I get 2 pi, 240 Henry, and 1 Henry. So XL2 is equal to 1822, and that's also 90 degrees. Right, so remember with our little triangle, this is my XL and this is my R. So since these two inductors are both pointing in the positive 90 direction and the positive 90 degrees, I can say XL is equal to XL1 plus XL2. And so adding them together, I get XL is equal to 2186 ohms at 90 degrees. So now that's the XL that I'm going to use to calculate my impedance. So Z is equal to, I'm going to do this as my angle. Actually, I'm going to calculate my angle first. So tan theta is equal to XL over R. So theta is equal to tan inverse XL over R. So my theta is equal to tan inverse of 2186 over 1500. So theta then is equal to 56 degrees. And so the magnitude of Z is equal to the square root of R squared plus this XL total squared. So Z is equal to 1500 squared plus 2186 squared, square root. So Z is equal to 2652 ohms, and the angle is 56 degrees. And so we're just calculating the impedance. Would go on if we wanted to calculate the current just by taking the voltage, which we weren't given, but then dividing it by that Z.